So I woke up that July morning to a sunny, beautiful day. Surprised to wake to phone calls from the National Weather Service, hearing that our river was at moderate flood stage and was still increasing. We were surprised because we really didn't have any rain to speak of, and the river was rising and rising. We didn't have good understanding as to why.
We didn't know where the flood was coming from, but we had a suspicion that it was coming out of Suicide Basin. So there was a group of us that jumped into a helicopter. We started flying up the Mendenhall Valley. We arrived at the basin. It was quickly apparent that this was, in fact, the source of the flood. We could see that the ice in the basin had collapsed down. There were stranded icebergs indicating the old water line at the beginning of the flood. We landed the helicopter. The ice was actually still cracking around us because the basin was still settling, and it was pretty clear that the peak of the flood had already passed because the basin was mostly drained.
We had streets that were flooded. It actually flooded power boxes from the utilities company. We had sewers that were near over flooding. We had some homes that were inundated, water into several garages along the same street.
We need to be able to make accurate predictions about the timing and the magnitude of the flood. To do this, we need to understand the ice dynamics in the basin, both how they've changed in the past and how they'll continue to change in the future.
So we're currently standing at the entrance of Suicide Basin, and what we see here, this big bowl, it was completely filled with ice as recently as 40 years ago. 40 years ago, Suicide Glacial that we see up there, remnant Suicide Glacial, was flowing into the basin, and the basin was full of ice. This ice was flowing out into main Mendenhall Glacier, and due to climate warming, this glacier has receded fairly quickly, or very quickly. And all of a sudden, rather than having ice moving out of the basin into main Mendenhall Glacier, we started having ice moving from main Mendenhall Glacier into the basin. A really cool feature that actually shows you how much that ice flow has changed is this side moraine that you can see in there. If you look at this moraine pattern in the middle of the basin, this moraine used to be all the way out here. And over the last maybe 20 years, this ice started flowing into the basin, and by now it's several hundred meters in the basin already. So we're actually standing on the ice dam right now. We're standing on the ice dam, which is still quite a bit higher than the water level. So the water level is rapidly rising right now because you have warm temperatures. We had a lot of rain over the recent days. And you can see how much meltwater is actually flowing into the basin. You see this back there in the waterfall, that's all meltwater from Suicide Glacier. And then at high water levels, which typically in midsummer, June, July, this water finds its way through the ice dam and the entire lake drains catastrophically. This dam, unlike a man-made dam, it's actually evolving over time. Here, because we have so much glacier thinning, this ice dam is thinning over time. And using drone elevation models and other elevation models, we have determined that this ice dam is thinning about 4 to 5 meters per year. Meaning that the potential water volume that's stored behind the ice dam is becoming smaller if the lake actually fills up all the way. But then we have another competing process. That's, if you look at the basin, it's full of ice, and this ice is actually taking away storage space that could otherwise be used for water. And we know from our measurements that this ice in the basin is melting considerably faster than the ice dam out here. So we have these two competing processes. We have the ice dam that is thinning at a certain rate, and then we have the ice that is melting in the basin even faster. And right now we're still in the process of figuring out which one is actually stronger. And to figure out these answers, we use drones. So what we have here is a DJI Phantom 4 Pro drone. That's a drone we have used so far for our work up in Suicide Basin. It's a great little drone, very nimble, that can do tight turns, which is actually quite important up in the basin where we have steep cliffs all around. The problem this drone has, it doesn't have a very accurate GPS, so we need to use ground control points in our structure for motion photogrammetry software, which is quite a bit of manual work.
So in this picture, I'm trying to find a ground control point, and there are known coordinates for it, and so I just have to find where that point is.
So today we're going to use a survey grade drone, a Vintra 1 has a much better GPS, and it's also a fixed wing drone, so we can cover the basin much quicker than with this DJI drone. This is a Wingtra 1 high precision mapping drone. It has real-time positioning, very high resolution camera, about a 42 megapixel camera, and it has survey grade GPS mounted inside, and so we can get about 4 centimeter accuracy with each camera position, and then that translates to high accuracy positions on the ground for each pixel within the photograph. So we use drones to fly over the basin, take pictures every 2 seconds in our case, and we process these pictures to get elevation models. And if you compare these elevation models over time, we can actually determine how fast the ice dam you're standing on, how fast it's thinning. And we'll also see the ice in the basin melting very quickly. So right now we know from drone measurements that the ice on average in the basin is about 40 meters thick, which is pretty thin by now actually. And if you lose maybe 6-7 meters per year, you're gonna lose quite a bit of ice. So we can do certain things using models, but it's very important to have equipment out here that looks at the actual process. There's a sensor that is sitting in that lake in there and measuring the water pressure and thus the water level at a certain time. Then we have the camera, it's visible right there, sitting on the slope of the mountain. That's a time-lapse camera that's looking at the basin and tracking how the ice in the basin is evolving over time. So right now it's taking a picture every day, and it's sending this picture up to a satellite. From a satellite, they're sent to our server, where all the post-processing happens. And then the post-processed images, they actually go up to a website that is hosted by the National Weather Service here in JUNEAU.
Really what we use the information from Suicide Basin for is advanced warning, alert and notification. It gives us an extra 24 to 36 hours to be able to alert homeowners that the water levels in the river basin are rising. So it gives them time to plan accordingly, to sandbag around garages and door entryways to keep water out of their homes. The Suicide Basin program has been a great showing of partnerships in the region of Southeast Alaska, but we've been incredibly fortunate by working with our partners in the National Weather Service, in USGS, and in the university. We've been able to develop real-time monitoring programs with mitigation actions taken by the public. So it's been great to have that 24 to 36 hours notice to be able to let homeowners know how to prepare, let the city know how to prepare, including our streets crews and our Forest Service and other partners in the community. This is a perfect example of how partnerships really bring the job home for public safety.
A decade ago, this flood hazard didn't even exist, and it'll be interesting to see how it evolves. Our hope is that the research methods we are developing will help to protect downstream residents in JUNEAU by improving flood forecasting capabilities. The tools will also benefit people living in other communities that are threatened by glacier outburst floods as climate warming continues to cause glaciers to recede.